Okay, so today we're going deep on something that's absolutely fundamental for any software engineer and especially crucial if you're gearing up for those senior level technical interviews.
Yeah, got it.
Control flow.
Control flow.
It's like the choreography of your code,
Hmm.
how it gracefully or maybe not so gracefully steps through all the instructions.
Absolutely. And at the senior level, it's not just about knowing how to write the code, it's about understanding the why behind your choices. Why one control flow structure might be a better fit than another in a particular scenario.
Right. It's all about demonstrating that you can build systems that are not just functional, but also elegant, robust, scalable.
Exactly. You've got to think about maintainability, long-term performance, all of that good stuff.
So to really equip you for these interviews, we're going to break down the essential control flow concepts, starting with branching, your good old if-else statements, and the switch statement.
Right. Branching is all about decision making in your code.
Exactly. And then we'll move on to looping with while, do while, and the for loop.
Gotta love a good for loop.
And we can't forget about those fine-tuning tools. Break and continue, which lets you kind of tweak how your loops execute, even using labels for more complex scenarios.
Oh, yeah. Labels can be really powerful when you're dealing with nested loops.
And finally, we'll wrap up with a solid look at local variable scope. Because let's be honest, scope can be a bit of a tricky beast sometimes.
Scope is one of those things that can lead to some really subtle bugs if you're not careful.
Okay, so let's dive right into branching. We've got to start with the if statement. It's like the bread and butter of decision-making and programming.
Yeah, it's the most fundamental way to introduce conditional logic into your code.
Yeah.
You've got a condition, and if that condition evaluates to true, then boom, a block of code executes.
Exactly. So let's say you're building a feature to calculate the average rating for a product. You've got a bunch of ratings coming in from users,
Well,
but what if no one's rated the product yet?
that's where the else branch comes in. It provides an alternative path for your code to take if that initial if condition isn't met. So in our example, if there are no ratings yet, maybe you just display a default message like, be the first to rate this product.
Right. Makes
Group.
sense. And of course, as your logic gets more complex, you might end up with multiple conditions to evaluate.
And that's when you bring in the if-else chain.
Yeah.
It lets you check a series of conditions one by one and execute the appropriate code block for the first condition. That's true.
So it's like a cascade of checks.
Yeah, exactly. And that final else at the end acts as a catch-all for any situation that doesn't match any of the previous conditions.
Okay, so we've got if and else, if and else. But as someone prepping for a senior role, I'm curious, when do you think all these nested if statements start to become a bit of a code smell?
That's a great question. Too many levels of nesting can definitely make your code harder to read and understand. It can become kind of like a tangled mess. And it might also suggest that there's a more elegant or efficient way to structure your logic.
Right, like maybe you can refactor it using different patterns or techniques.
Exactly. Maybe you can introduce guard clauses or use a lookup table or even consider a state machine if you're dealing with really complex state transitions. At the senior level, it's all about recognizing these patterns and choosing the most effective approach.
So moving on from if statements, we have the switch statement. It's a really nice way to compare a single value against multiple possibilities.
Yeah, it's great for situations where you have a known set of discrete values and you want to take different actions based on which value you're dealing with.
And what's interesting is that in modern Java, we now have two main forms of the switch statement, the switch expression and the traditional switch statement. So what's the key difference between these two?
The main distinction is that the newer switch expression is all about producing a value. It's like a concise way to map an input to an output. Think of it as a function that takes a value and returns another value based on a set of rules.
So it's almost like a more powerful ternary operator.
Yeah, you could think of it that way. The traditional switch statement, on the other hand, is more about executing a series of statements based on the value of an expression. It doesn't necessarily return a result directly.
Okay, so let's say you have an HTTP status code as an integer, and you want to map that to a human-readable string message. How might you do that using a switch expression?
Well, it's pretty straightforward. You'd have your switch keyword followed by the variable you're switching on, and then a series of case labels, each with an arrow pointing to the resulting value. So something like case 200 arrow, okay, case 404 arrow not found, and so on.
I see. So the arrow syntax really emphasizes that you're returning a value for each case.
Exactly. And the whole switch expression itself evaluates to one of those values, which you can then assign to a variable or use directly in another expression.
Now, what if you need to do something more complex than just returning a single value for a given case?
Well, in that scenario, you can use curly braces to enclose a block of code for that case. And within that block, you'd use the yield keyword to specify the value that should be returned for that specific case.
So it's kind of like having a mini function within each case.
Yeah, precisely.
Yeah.
It gives you more flexibility when you need to perform some additional logic or calculations.
Okay, so that's the switch expression. Now let's talk about the traditional switch statement. How does that differ?
Well, syntactically, the traditional switch statement uses colons after the case labels instead of arrows. And instead of directly yielding a value, you typically have a series of statements within each case block, often including assignments to variables.
And I remember the importance of the break statement at the end of each case to prevent execution from falling through to the next one.
Yes, that's a crucial difference. With the traditional switch statement, without those break statements, the code will just keep executing down through the subsequent cases, which is usually not what you want.
Right, so you have to be really careful about those break statements.
Exactly. It's a common source of errors, especially if you're not used to the fall-through behavior.
Okay, so as a senior engineer, you've probably seen both forms of the switch statement used in production code. Do you have a preference for one over the other?
I'd say in modern Java, I definitely lean towards using the switch expression whenever possible. It's more concise, the error syntax is very clear, and the fact that it explicitly returns a value makes it easier to reason about the code. But of course, there are still situations where the traditional switch statement might be a better fit. Maybe you're working with legacy code, or you have a very specific reason to rely on that fall-through behavior.
Right. I guess it's all about choosing the right tool for the job.
Exactly. Now, another important consideration is what types of values can you actually use as those case labels in a switch statement or expression?
If I recall correctly, you can use primitive types like char, byte, short, and int, as well as their corresponding wrapper classes. You can also use string literals and values from enum types.
That's right. And the reason those types are supported is that they generally allow for efficient comparison, which is kind of a key advantage of using a switch statement.
And you can even have multiple case labels leading to the same outcome, right?
Absolutely. So if you want to treat multiple values the same way, you can just list them all before a single arrow in a switch expression, or before a single code block in a traditional switch statement.
That can really help reduce code duplication.
Definitely. Now, one thing to keep in mind with switch expressions especially is that they need to cover all possible input values.
Right, because they have to return a value for every input.
Exactly.
Mhm.
So you either need to have a default case to handle any values that don't match your specific case labels, or you need to make sure that your case labels exhaustively cover all the possibilities.
And if you don't do either of those things, and an unexpected value comes along, what happens?
Well, in that case, an exception will likely be thrown at runtime.
So it's really important to think about those edge cases.
Absolutely. You don't want to leave your code vulnerable to unexpected inputs.
Now, speaking of exceptions, what's a common runtime error that developers need to watch out for when using switch statements or expressions with reference types like string or enums?
Ah, yes, the dreaded null pointer exception. It can rear its ugly head if the expression you're switching on happens to be null.
Right, because you can't switch on a null value.
Exactly. So if you're working with reference types, you always need to be mindful of the possibility of null values and handle them appropriately, either with a specific case null, if that's allowed in the Java version you're using, or by checking for null before the switch statement.
Okay, so we've covered if statements and switch statements. Now let's move on to loops, which are all about repeating a block of code multiple times.
Loops are essential for automating repetitive tasks and iterating over collections of data.
And the simplest type of loop is the while loop. It just keeps executing its code block as long as a given condition is true.
Imagine you're reading data from a file. You don't know in advance how many lines the file contains, so you'd use a while loop to keep reading lines until you hit the end of the file.
Right, so the condition would be something like, have we reached the end of the file yet? And the loop would continue as long as that condition is false.
Exactly. Now, sometimes you need to ensure that a block of code within a loop runs at least once, even before the condition is checked for the first time.
And that's where the do-while loop comes in.
You got it. With a do-while loop, the code inside the do block is executed first, and then the while condition is checked. If the condition is true, the loop repeats, otherwise it exits.
Okay, so a classic use case for do-while might be prompting a user for input until they provide valid data.
Yeah, you might keep asking them to enter a password, for example, until they enter one that meets the security requirements.
And since you need to ask them at least once, regardless of whether their initial input is valid, the do-while loop is a good fit.
Exactly. Now, when you have a situation where you know in advance how many times you want to repeat a block of code, or at least you have a clear initialization condition and update step, then the for loop is often your best bet.
Yeah, the for loop is really great for iterating over collections like arrays or lists.
Right. You typically know the starting point, the condition to continue, and how to update your counter variable.
And what I find interesting is that any for loop can technically be rewritten as a while loop and vice versa.
Yeah.
The underlying mechanism is pretty similar.
That's true.
Yeah.
But the for loop just provides a more structured and often more readable way to express those common iteration patterns.
Right. It keeps all the loop control logic neatly packaged together in the header.
Exactly. Now, the for loop is also quite flexible. You can have more complex update steps, or you can initialize variables outside the loop and just use them in the for header.
And you can even have multiple initialization or update statements separated by commas if you need to manage multiple variables.
Yeah, that can be useful for more intricate control flow.
And just as a side note, if you omit the condition in a for loop, you essentially create an infinite loop, which will keep running forever unless you explicitly break out of it using a break statement.
Which brings us nicely to our next topic, break and continue. These keywords give you more fine-grained control over how your loops execute.
So the break statement provides a way to immediately exit out of loop or switch statement.
Yeah, think of it as an emergency exit. If you hit a certain condition and you just need to get out of the loop right away, you use break.
So a classic example is when you're searching for a specific element in an array. Once you find it, you don't need to keep iterating through the rest of the array, so you can just break out of the loop.
Exactly. It can save you unnecessary processing time.
Now, the continue statement is a bit different. Instead of exiting the loop entirely, it just skips the rest of the current iteration and jumps to the next one.
So if you have some condition that means you don't want to process the current element, you can use continue to skip over it.
Right, like if you're reading a file and you encounter a blank line or a comment line, you might just want to continue to the next line without doing any further processing.
Makes sense. Now, for more complex scenarios involving nested loops, you can use labeled break statements.
Yeah, that allows you to break out of an outer loop from within an inner loop.
Exactly. You just assign a label to the outer loop and then use break followed by that label to exit that specific loop.
So if you're searching for a value in a two-dimensional array, you might use labeled break to exit both the inner and outer loops once you find the value.
Right. And there's also a labeled continue statement, although it's used less often. It would jump to the next iteration of the labeled loop.
Now, as a senior engineer, I'm sure you've seen your fair share of break and continue statements in code. What are your thoughts on their general use?
Well, they can definitely be handy in certain situations, but I think it's important to use them judiciously. Overuse of break and continue can sometimes make your code harder to read and understand. It can create multiple exit points within a loop, which can make the flow of control less obvious.
Right. And often the same logic can be achieved by restructuring the loop's condition or using Boolean flags to signal when to stop or skip.
Exactly. So it's all about striking a balance between conciseness and clarity.
Okay, let's move on to a really fundamental concept, local variable scope. This determines the lifespan and accessibility of your variables.
Right. Understanding scope is crucial for writing clean, maintainable code and avoiding those pesky naming conflicts.
So first things first, what exactly is a local variable?
A local variable is any variable that you declare within a method. This includes the parameters of the method as well.
And its scope is the region of code where that variable is actually accessible.
Exactly. In Java, the scope of a local variable typically extends from the point where it's declared to the end of the enclosing block of code, which is usually marked by curly braces.
So if you declare a variable inside a while loop, its scope is limited to that loop. Once the loop finishes executing, that variable is gone.
Right, and each time the loop runs again, it's like a fresh instance of that variable is created.
So how does this work with do-while loops, especially when it comes to variables used in the loop condition?
Well, because the condition in a do-while loop is checked after the do block is executed at least once, any variable used in that condition often needs to be declared outside the loop.
Otherwise, its scope wouldn't extend to the condition and you'd get a compiler error.
Precisely.
Yeah.
Now, what about variables declared in the header of a for loop? What's their scope?
If you declare a variable in the initialization part of a for loop, its scope typically covers the entire loop, including the condition and the update statement. But once the loop finishes, the variable is usually no longer accessible.
Right. So if you need to use the value of that variable after the loop, you'd have to declare it outside the for loop.
Now, key rule to remember about local variable scope in Java is that you can't have two variables with the same name in overlapping scopes.
Yeah, that would just create ambiguity and potential errors. The compiler wouldn't know which variable you were referring to.
So you have to be careful about reusing variable names.
But if the scopes don't overlap, you can reuse names. For example, you could have two separate for loops, each with its own counter variable named, as long as those loops aren't nested or within the same block.
Right. So it's all about understanding how scopes interact.
Exactly. Now, before we wrap up, I just want to emphasize that understanding control flow and variable scope is absolutely crucial for any senior software engineer.
These are the building blocks of well-structured and maintainable code.
In a technical interview, being able to articulate these concepts clearly and demonstrate your ability to choose the right control flow structures for different scenarios will really make you stand out as a strong candidate.
It shows that you're not just a coder, but a thoughtful and experienced software engineer.
Exactly. So as you continue your interview prep, take some time to really think about concrete examples of how you've used these control flow structures in your own projects. Be ready to discuss the trade-offs and the reasoning behind your choices.
And think about how these fundamental concepts empower you to build more robust and scalable systems. That's something every senior engineer should be able to articulate.
Thanks for joining us for this deep dive on control flow. It's been a great discussion.
Absolutely. Until next time.